If you hear the words BASF, performance, plastics and simulation, then the next word which is about to come is Ultrasim. Ultrasim is BASF's approach to do CAE simulation and co-creation for the development of parts with our customers. We offer Ultrasim in projects, and Ultrasim is much more than just a material modeler for finite element experts, because Ultrasim is able to take the process simulation properties on the one hand into account and map those properties to the mechanical simulation. So Ultrasim is a really holistic approach. If you look at this part here, which is an energy absorber of a passenger car, you see that the crash behavior here is quite complicated. You'll never get that with standard material models in the right way, so that you can predict the energy absorption and the failure and the force and everything. And this is only possible by Ultrasim. We did that together with a customer from the OEM industry and together with a Tier 1, where the Ultrasim software was installed at the customer and at the Tier 1 as well. But let's face it, Ultrasim Classic, as we call it now, is a tool for experts. You need finite element guys, you need the CAE guys, you need the computer nerds in order to do all those things. But this is now about to change. What we will present you in the next minutes is what we are doing in terms of putting Ultrasim on a new level, putting the Ultrasim technology and making it accessible. Matthias.
Thank you, Andreas. I hope, please go one back here. I think Andreas convinced hopefully everybody that our simulation technology is really a proven and valuable tool to make successful plastics parts. So what we thought, okay, we are of course continuously improving it, but the most important thing is that our customers are actually able to use it in basically all of their projects. So now the big step is, how can we make this technology available to as many customers and as many part projects as possible? And then the first step is that we take this from an expert tool to an online tool, where all of our customers can register and do their projects on their own. The other important thing is we also have to make small apps, easy to use apps, so that not only the experts, but everybody involved in this part development process can actually use it. Yeah? So we want to really target not just the CAE engineers, but one step earlier, everybody who thinks about a plastics design should be able to use it. So in order to use it, I think let's have a look. How easy should it be? It should be as easy as upload your part design, press a button, run the simulation, see the results, analyze the results, ask your colleagues for help, ask our support for help, and then take a decision if you need a change or if this is going to be a successful design. So let's now do some reality check if our tool model it is as easy to use and quick as we promised here. So this is now some live demo in the internet. This is when you log in. It's our dashboard where you see your current projects. So let's now try to start a new part project. We simply start it, give it a title, then we upload our geometry, push it through the internet here. So now you can see we already have a preview here. It's an electronic housing. If we want, we can already set some injection location or put it to auto manual. Then we can select some material if we want from our portfolio. So there's a comprehensive material database in there.
So Matthias, all that is now really happening online, and there is not just something prepared locally. Yeah. It's on the cloud. Exactly. So this is happening right now in the internet, running on a European Azure server. The only thing that you need is a modern browser, your CAD file, your idea, and then you can already get started. So this runs in Chrome, in Edge, whatever? Whatever you have, what is the common technology. Yeah. Matthias, what is happening with the data that the customer uploads? Yeah. So of course the ideas of our customers, they are of the biggest value for us. So if you upload something, you are the only person who can actually see it.
and you have full control over your data. You can control if you want to share your part with a colleague or you ask our support, but it's not shared with anyone if you don't ask for it.
So now it's already run?
Yeah, but so we can see the first simulation was already conducted here. For example, now we have a part. For example, you can look at the thickness distribution of the part.
The thickness might be important for avoiding higher cycle times because of mass accumulation.
Molding, yeah. We already get some estimates here for things like fill time, cycle time, pressure requirements, flow lengths, things like this. Yeah. And we can also, very important, we can directly inspect here also the filling behavior of this part. Yeah.
So what about having some kind of guidance for the injection molding?
Yeah, exactly. I think this is a very important topic here because we want to offer this to non-experts. So we have a built-in guide that tells you for the different results why it is important to look at it, what might be measures that you want to take. Yeah. Or if you cannot make a decision on your own, of course our technical support is only one click away. You can onboard him into the project, say please help me and give me your expert advice.
Matthias, what about now trying to find out what happens if you have two gating points, for example?
Let's try this out. Now we have this. So we simply put on here on changes. We want to put a manual injection location. We put here on one side, maybe on the opposite side. And we can simply run another simulation live here and hopefully get some result within a few seconds.
Yeah, there might be a weld line in the middle, which of course is for the mechanical performance a weak spot. So with those tools you can easily detect if there are some weak spots and see the weld lines. Yeah? And as I can see on the upper line here, there is a weld line button, so we can also visualize this one.
Yeah, so maybe let's have a look here on the weld line result. If we are seeing something, it's loading. Let's switch to weld line.
Yeah.
And as you correctly predicted, Andreas, we will have a big weld line here and some smaller weld lines here. We can also track this visually.
It's clear to see. Yeah?
You can clearly see how the weld line is generated. And yeah.
You talked about collaboration. What does that mean? Now, if I have done such a simulation, I want to share it with some other guy.
So collaboration, I think, is a very important aspect here. It's not about a self-service tool, a cost-cutting tool. We really want to make collaboration easier. A collaboration between different project partners within our customer company, but also collaboration with our in-house experts. Yeah.
Perfect. Let's have a look at more results here. Maybe we put the fiber orientation. This is something which is also important. In our Ultrasim tool, we use that fiber orientation approach in order to make better mechanical simulations, taking into account the anisotropy. And the molded tool has also some abilities to show the fiber orientation. And if you know about your mechanical results, then you can judge, hey, that could be a problem if you have the highest load and the highest stresses in the region where your fiber orientation may be disturbed. Yeah? But then, as Matthias already pointed out, you can click on the support button and we can have a look at those parts with a much higher accuracy and with our Ultrasim Classic tool by clicking on support and telling us the problem that you have with that part.
And it's definitely maybe some result you want to keep in mind for 1 minute because it is a complicated result. You just cannot look at it and then see what is the fiber orientation. It's a tricky result, but we will learn in a minute what you can use and what you can do with this result actually.
Okay. So let's switch back.
Exactly. So now, of course, the question is, I mean, injection molded parts are not covering all of our material portfolio. Our portfolio has at least two sides, like this shoe here. It's an injection molded TPU, but it's also some foamed PU system sole here on the top.
Yeah. And the thing is, what we showed you now is the first app that we have here, but there are more, and there are more to come. So at ultrasimweb.basf.com you should look what's going on. And this, I think, is a nice example because this is the molded side, basically, and the other side, you know, this is made from a foam. You can also use the foaming app, which is available on our web portal in order to look what the foaming can do and to help you to also avoid mistakes with the foaming process in early stages.
Exactly. So, and I think when you remember what Andreas told earlier, there basically is the one side of doing the processing right, but then also predicting what this process is, and the part design give you some final part performance. And of course, we also created app for this. Yeah, we won't go into details here, but you can visit us at our booth. For example, in the make area, there's a tool that will actually take the fiber orientation that we saw a minute ago and will incorporate this into some highly nonlinear material model where they can do highly accurate mechanical part simulations.
So we are at the end of our talk. I hope we gave you an introduction into what we want to do. As I said, we want to shift gears. We want to bring the Ultrasim technology that has been proven over years to all our customers who want to do that, who want to use it in early phases. And if you want to know more about, it's just a step away, so you can visit us at the K-Show here at our booth, and we can talk in more detail about what you can do in order to create better parts. Thanks for your attention.
Thank you.
BASF. We create chemistry.